What's up, guys? We made it to Friday, and I haven't coded in the past few days. It's since the 23rd. It's been that long. 23rd, was that Monday? So yeah, so it's been since Monday. I'm actually been really busy with other life things, and I'm sure you know how that goes. Life is always busy. Pulled a muscle in my back or something. It's like pretty bad actually. I work at UPS, very hard on my back. I work out really hard at the gym and stuff, and I don't know. I think I was doing some decline sit-ups. I've since quit doing those because I think they might have contributed to it. And then I fell skateboarding. Not like terrible, I just like fell on my ass. It wasn't like a bad, terrible fall, it's kind of hard. But man, I've been dealing with back pain. It's like pretty bad. You know how it is. You just gotta deal with it. Take a shit ton of anti-inflammatory, and I don't want to take any pain medication. I don't really like how it makes me feel. I'm prescribed it actually, but I don't like to take it. Anyway, so hopefully y'all are doing well and feeling good. It's a little bit of a late start, but I have been busy doing other things, and I need to stay in touch with the project. I can't get away from it for too long without, forgetting where I was at, forgetting critical things that I need to remember. So here I am. Let's just jump right back in and pick up where we left off. Hopefully, at least, hopefully we're not forgetting anything that I was supposed to remember. Alright, so, yep, today's the 27th. It's Friday, started at 1:53. We're going to go to things to do and look at what we got going on here. Actually, let's look at this devlog from the 23rd and see what it says. So, we finished working on replacing eval instances with regular if-elif logic to improve performance in the entire project. We tested and verified everything seems to be working 100%. Thought we did. So I remember doing more testing, and I could have sworn that we had some issues. Oh yeah, I got my card shirt on today. This might be like the first time I wore it on stream. I bought this in commemoration of this project that I've done. But anyway, let's see if we can pull up this here stream, make sure it's working, and post it. Alright, yeah, it looks like I'm there talking. The man himself, there he is. Young, dumb, and broke. Yeah, pretty much. Alright, that looks like it's working. Actually, I didn't wait to see if it was really working. Okay, yeah, there I am. Alright, let's continue. So we are. I remember we were doing game testing. Okay, so what is it? Control terminal. Control tilde expands or collapses the terminal window. And then we do Control Shift 5 twice, we can duplicate that. So we're going to CD to Canasta main. We're going to do the same thing for the other two instances of terminal. And I'm just going to crank up the script, the server, and also the client real quick. And I want to see if we can get this running, see what sort of state the game is in, just to make sure there's not like a critical crash bug going on here. I want to address it before I make any changes. Oh, and look, there's that bug, the waiting for the other player to join the server bug. It's funny. So let's see, what got sent. I guess I'll just go ahead and address that bug then, since it showed its head. I thought it was gone maybe, but it's still there. It's rare though. but it does still happen apparently. So at this point, it's like a 1 in 30 chance. Roughly. So yeah, we did encounter it. Okay, so let's see what our output was. Our output was, and we're looking at the client here. Well, let's look at server first. So we have setup, create double deck, the draw one, and then we have a keyboard interrupt. That's when we killed the script. And then we have on the client one, it sent out game state waiting other player, and it never actually moved on from that. Client 2 was never able to really do anything except run setup and then get terminated through that keyboard. On its end, it looked like a connection there. Server, always forget how this works, so we run the setup, then we have the draw one, and we have player. Let's look for that. Self game state. Da, da, da. All right, so here we go. This data never gets sent. It enters into the draw one, and it changes this data for the current game state. And again, yeah, that is the case. That did not get sent. So that's what's supposed to happen, is the draw one is supposed to run once both of the clients are connected, right? So it's, let's see, start accepting clients. Yeah, so it's, yeah, start accepting clients will not continue until both clients have been verified as connected. So as long as at least one of them are offline, meaning that their online is equal to false, then we remain trapped in this while loop on the main thread. Is that right? Yeah. Yeah, because this is a main thread run function. Yeah. Let's go down here to name's equal to main. Yeah, so we have the server dot bind to server listen, and then start accepting clients, and then we end up having a setup run. So both clients become verified as online when this happens. This is not an issue wherein the game is stuck in a state wherein both clients, where we're actually still waiting for one of the clients. The two clients have actually already connected. They have already bin locks main thread via while loop until both clients are online. Yeah, so then after that, on the main thread, we run. I don't think we need this Pygame display set mode, right? On the server side. Yeah, we don't need that. Pretty certain. Can disable that. Let me see something real quick about that. I want to check this. Oh no, I do have to do it for Pygame transform scale. So to assign the face down image, okay. So we can modify that in the future. I'm not gonna worry about that right now. This is not a huge deal. Let me change this real quick though to reflect today's date. We're gonna create a new little note here that says 9/27/24. Do we need to do the server side? We'll say necessary server side only because we haven't modified setup to run without assigning card images. We can easily modify this section so that we don't have to run this code at all, which is preferable because we don't use display on server side. So running any of that code is just like asking for bugs when we could have less code and less bugs. It's just better. Anyway, so back to the waiting other player issue. So let's see. We have so the issue here is that it runs the draw one, which will go here to the draw one, and then almost immediately the first thing it does is it sets P1 and P2's game to their game states to the draw one. And I just wonder, why is this not being transferred? So let's go over to server and let's look up all of the instances of the logger function to find this specific log we're looking for. So this is going to be in the send section. This is receive. What's this one? Receive verification. Resending. Okay, start send section. C1 change attribute list is populated. So this is never printing because we didn't get that printout. Let's just verify. Yeah, well that's a different instance. Let's see here. So we just have the draw one, and then yeah, we don't get that run at all. It's not printing on the server side. Okay. And then it's also not printing. C1 change attribute list is populated after initial pop check. So neither one of these. So this means that the changed attribute list is not being populated in this case. Okay, I'm like, whoa, this might actually be what's happening here. That's would be crazy though. Where, oh, but we use a lock, so that should solve that issue, right? Like, so we use the C1 cal lock here before we check the length of the attribute list, okay? And then in change attribute list, which is where the function that appends this data to the change attribute list exists. And see, we have those logs disabled, damn it. Because it's a lot when it, you know, this is such a rare bug. I don't like to have this enabled every time. It's such a pain in the ass, man. Because I just can't replicate it. It's so random. But, ultimately, it looks like what's happening here is, for whatever reason, it is not. So it's entering into this. My concern was maybe that when we run this function, because the way it works is from start to finish, we have the server main thread, which is running progression. Progression enters this line, which iterates through each game, changes the game state of each one to the draw one, and this in turn will trigger the game state let's see, just look for def game state. So then we have the game state calculated property, which forgot to set my timer. Any day now. Okay, there we go. So forgot to set the timer. It's set now. So we have the setter. It's funny, set my timer. Setter. The setter for game state gets called, and if the type of val is not equal to tuple, which it wouldn't be in this case, it would call the data transfer function, passing in the self ID as the cal object int, which is surely going to be correct, the game object, which is the self, which is surely going to be correct, and then it passes in the cal tup, which has game state, and val. Okay, so then we go to change attribute list, which has the data transfer function, takes cal object int, game object, and cal tup. It assigns global SS or CS, global change attribute list, pi client ID. What is that used for? CS. Okay, this is only for client side. Gotcha. Alright, so we don't have to worry about that. Then it uses the lock. Oh wait, looking at the wrong function here. Okay, so yeah, cal object int, game object, cal tup. We summon all these globals, global transferred game adders, all these apply counters. That's fine. We get the current time. The adder name string is equal to cal tup at 1. We already checked all this. 0, 1. that is the adder name string game state. We already took care of that. Um, then, and we know this works. It's intermittent. It works most of the time. So then we assign the C1 change attribute list. Ah, you know what? This might be the problem right here. It might be a race condition because we pass in the cal object int. Well, so technically we should use the cal lock here for that because we are like creating a reference to an object. Let me ask ChatGPT how that works. Let's think about this for a second. So we have a shared object. Yeah, I think we would need the lock here because let's say we're modifying this list like at the same exact time. But this wouldn't actually be a problem because like real world scenario, this wouldn't be a problem because this is where the change attribute list gets like modified, but from like a rules, safety, security perspective, this is a race condition vulnerability technically because the C1 change attribute list is a shared object. So I'm quite certain it is. Of course it is. Let's just verify this. It's pretty positive it is. Okay, so right here we... Oh, we're not using the lock here. Oh yeah, we don't have to use the lock client side. Duh. Gotta make sure I'm alive and well here. But isn't it? Well, let's see. Let's go to custom time list. Don't worry about that. Deck. Game player. Yeah, so we use the cal lock here. But we actually only have to do this in the case of being on server side. I mean, yeah, we only have to use the lock if we're server side. But I don't think that SS or CS would be set at this point in time. SS or CS would not be properly set until setup is run, and setup is run after all of these modules are initialized. We probably should sort of code we should probably put this in setup, like the initialization of all objects, instantiation rather, of all these class instances should probably exist within the setup function to where it all happens like in one centralized place. But I'm actually not gonna do that right now. I'm not gonna worry about that. It's not really an issue. I'm pretty positive like there's nothing actually wrong with doing it the way we're doing it. It's like an either or thing. You could do it either way or the other. But let's continue. So we have the C1 change attribute list. Now this is server side. And you can see here we acquire the C1 cal lock. Alright. And in the case that let's see, we have if current ID is equal to 1, C1 catalog acquire, and then we release it immediately after. Okay, and this should actually happen first. Okay. Yeah, so we do use a lock with the C1 change attribute list. I was pretty sure of that, now I'm positive. Okay, so let's go back to change attribute list. So we know that we should be using a lock. And since this function will always be called after setup has been run, we can safely we can definitely use the lock, but we only would need to use this if SS or CS is equal to SS. So let's check that first. Let's see. If SS or CS is equal to SS, then, well, actually, we still need to assign the cal object. So we should then say if SS or CS is equal to SS. Well, we can just check this first, and then we can say from SS equals true, and then we'll put this equal to true. It's going to start off as false, and then if we have it set to SS, then, well, that's silly. That's the same thing as checking if SS or CS. Like, why would we create another? Yeah, that's a silly solution. We really need to so we'll just put this here, and then we'll put with C1 cal lock, and C1 cal lock is, let's see, so we actually, yeah, this is where C1 cal lock is actually created, so this is the location of it. So we would say with C1 cal lock, we would then say cal object equals C1 change attribute list, and then we'll say else, meaning elif SS or CS is equal to CS, which is if making the change inside. And then this, let's do the same thing again. Just paste over that. So then else, which is elif cal object in is equal to 2. Then if SS or CS is equal to SS, we with C2 cal lock, cal object equals C2 change attribute list, else cal object equals C2. So the only difference here is if SS or CS is equal to SS, we use the C1 or C2 cal lock, but if it's equal to CS, then we just directly assign the cal object because we don't need to use the lock since there's no multiple threads competing for the object. So let's just verify this code. So we have if cal object int is equal to 1, that means if we're dealing with client 1, then we check SS or CS equal to SS. Okay. And if it is, we then use the C1 cal lock, and that's 1, not 2, because we're dealing with client 1, to assign the cal object variable equal to the C1 change attribute list, and then else, that's the same as saying either if SS or CS is equal to CS, making the change from the client side, cal object is directly assigned without using the lock to C1. And then we have else, which is elif cal object int is equal to 2. If SS or CS is equal to SS, we then use the C2 cal lock using that with context manager and assign the cal object to C2. Then we have the else, which is if we're changing it from client side. We then have the cal object assigned directly to the C2 change attribute list without using the... Okay, so that shouldn't have been the cause of any bug. Let me just think about it for a second. Pretty sure that wouldn't have caused any application. But yeah, anytime we invoke the name of the almighty C1 or C2 change attribute list, we have to use a lock. Otherwise, we're going to be dealing with race condition issues. So that actually makes me, this looks like a race condition issue where, well, I mean, it's intermittent, so it's not like a hard bug. You know what I mean? It's not like a... When I say hard bug, I mean it's not something that is broken all the time. It's something that's causing for whatever reason, this function to be run, the data transfer function, it gets past all this stuff. This should work up to here. All this, I mean, this is on the main thread. We get down here to the draw one. At the very beginning of the draw one, we run this line, and of course this line is going to be run. I'm just trying to see, like, is there any way this line wouldn't be run? Well, no, because it's explicitly called. So 764. It's explicitly called from server. So there's no way we could avoid running that. Like, it definitely calls this function, which means the main thread definitely is gonna run this line, which is gonna run this line, which is gonna trigger this game state setter, which is going to in turn trigger this else, which is going to call this data transfer function, and we verified all of this looks correct as far as the data being passed in. And we know it works sometimes, so yeah, I was gonna say maybe it's a game, like a bug with game state not being in the proper directory or whatever as far as data transfer, but that's not gonna be the issue because we know it works most of the time, 90-ish% of the time. So then that's gonna trigger data transfer function. It's gonna do all this cool stuff, and it's gonna have the proper attr name string. We already know that because it works most of the time. It's then gonna assign this cal object to the proper change attribute list, and then So, and then it's going to check if SS or CS is equal to SS, which it will. I'm trying to think, is there any way that it wouldn't be equal to SS? Well, no. We know that it would be because setup gets run first and setup assigns that. So that is definitely not the issue. Because, well, hold up. Let me think about this for a second. What if, so let's look at how this works again. On the main thread, we have start accepting clients, okay, and then we run setup. But we run setup before we run the draw one. I was thinking though, what if, let me try to talk my way through this. What if we're running setup and then well, no, that couldn't. Yeah, that doesn't work because my little thought experiment. Yeah, it doesn't work like that. So the setup gets run on the main thread, which sets SS or CS, and then on the main thread the draw one gets run, which changes the game state. So there's no way that we could get to this point in time when we have changed the game state, which is what would call this function in the first place, and SS or CS not be correctly set. So we know pretty much up to this point in time, all the code is good as far as I can see. So then let's keep going. If calloc is equal to 1, we already, well, we didn't actually look at this. If calobject in is equal to 1, yeah, we know that works. Lock equals C1 calloc. Okay, and then if adder name string is not in transferred game adders, increment both counters, blah blah blah. Okay, that's fine. And then we create the cal tube, and there should be no conflict with using this. I don't see anything wrong with that. So now we have SS or CS equal to SS, calloc list function. So then we pass in the cal object, the string A for append, the cal tube, and the, where do we get the cal object from? The cal object is assigned up there, okay. Oh, see, we need to use the lock with this. This might be an issue here. We might, because yeah, we should use a lock here because the cal object is the C1 or C2 change attribute list. So this actually needs to be with cal lock. Yeah, we definitely need to use the cal lock, but we don't have access to the cal lock. So this is, well, actually what we do is just assign, it's called lock. So with lock, we would then do that. Must use this since we handle cal object, which is the original C1, C2 is a shared object on server side. True. So, I don't know, maybe this was the issue. It could have been. I don't think that would have been the issue though. I mean, technically it could, right? Like technically it could have went to go to append this because it never gets populated according to the logs. And this line is the one that causes it what is this? I don't know, this is gonna give me a fucking copyright strike, huh? I don't know this shit. Where did it come from, bro? Like, how did that get in my playlist? I swear, dude, sometimes stuff gets in my playlist and I'm just like, how did that get in my playlist, bro? Where we at here, boys? So let's see. With lock. Okay, so this technically could have been the issue. And I notice here, I'm actually using the I assign lock here because I end up using the lock right after. It's fine. I was gonna say, since I'm using the lock up here, couldn't I assign it? We could just say lock equals. So yeah, since this checks for SS or CS, they both check SS or CS. Okay, so this is where we assign the cal object. I was seeing how does this code work? Like, why do we have these two in two separate sections? It's because we have to have the cal object either way. We have to have the cal object if it's being run from the SS or CS. But what we can do, and that's all fine, I'm sure we could probably reduce this by a few lines and optimize this logic a little bit. As I'm looking at it, like I'm no, this is fine. We'll leave it as it is. The only thing I'm gonna change is right here. We're gonna assign the lock. We're gonna say lock equals, what's it called? C1 cal lock. Lock equals C1 cal lock. CL. Did I put C1 cal lock? And then we're gonna change this one to be lock equals C2 cal lock, and then we can say with C2 cal, or with lock rather, and then same thing here. So we have checks the object ID int, checks SS or CS, assigns the lock since it's on SS, we'll need it, and then we say with lock, we use the context manager to deal with the associated lock object. Else we just assign the cal object, and then else if it's to SS or CS is SS, we assign the lock to the C2, and then we use that lock with the context manager to do the same thing, except we then assign it via as with C2 instead of C1, and then else, which is in CS, we assign the cal object directly to C2, and then we don't have to assign the lock here again, because if SS or CS is equal to SS has already been run, we don't have to which it has been, then that means we we don't need to reassign it again. So we just have it assigned once initially, and then where's the other? There it is. This line right here, lock equals C2 cal lock. So this has already been assigned. Also assigns lock, whereas it doesn't do this anymore, so we have to fix this. So assigns proper lock to be used later, immediately after. Oops, whoopsie. Now let's go over here, and of course I forgot the colon. Let's copy this comment and go down here, paste, here we go. Now when we run this section, we will surely use the lock, which we didn't have this before. And this may have been the bug, guys. I may have found it. I'm not positive on that, but I think I might have. I'm actually hopeful. Okay. So then let's move to the next step. We have cal lock list function, which uses the cal object, passes the cal object, which is the attribute list, the a string for append, the cal tube, and then the lock. Yeah, I don't see anything wrong with that. So then let's go look at cal lock list function, which is right here. So a list is going to be the cal object, then the a string, okay, then the data, which is going to be the cal tube, which should be good, and then the lock, which is indeed that lock object. And you can pass lock objects like through functions and stuff, and they still should work and refer to the same object. Yeah, I don't see why they wouldn't. It's just like any other like instance class instance object. I think that's probably what it is. It's an instance of like the lock class or whatever. And so we then use the lock. Well, is that circular? Because yeah, we're actually, that's not circular, that's so can the same thread acquire a lock twice in a row without that? I don't know the answer to that question. So let's see. Let's ask old Chibbity Jibbity. Can the same thread acquire a lock twice in a row without releasing between actions? on a regular threading lock object does not allow the same thread to acquire the lock without releasing it first. If a thread attempts to acquire the lock while it already holds it, the lock, waiting for itself to release the lock, which results in a dead lock. Provides threading.rlock, which is a re-entrant lock. It's the same thread to acquire. Oh, see, I never understood what the reason for lock was. I didn't understand it. See, understand now. I just had new knowledge unlocked. Understand. So we should probably use re-entrant locks. The thread must release the lock the same number of but then you have to release it the same number of times it was acquired for it to be fully released. Now that is bonkers. That is odd. This is useful when a lock needs to be acquired multiple times within the same thread, such as in recursive function calls. Okay, well, as long as you're using... I don't know about this, boys. I don't know about the re-entrant lock thing. That seems strange to me. That seems like asking for problems. To have a lock that can be acquired twice, and then it has to be released twice. So if you forget to release it, like, well, I mean, it's not a huge deal, but it's just, I don't know. I'm trying to think of it. Yeah, we actually would have to do this. Like, there isn't a way around this, actually. Yeah, we actually have to use a re-entrant lock if we want to use a lock to call a function that is past the lock and is then that lock is used again recursively. There isn't a way to do that without, like, you can't. It's like an impossibility. So lock acquire. So we have lock equals starting our lock. Define task. Lock acquire. So we acquire the lock the first time, then we call acquire again, and it does not block. Lock release the first time, and then lock release is fully released. That's a terrible example, but yeah, technically you could do that, but that is a terrible example. So what we're gonna do, we're gonna do the thing. We're gonna do the thing with the re-entrant lock. Okay, let me put that in things to do. We don't need reminders. We don't need to look at reminders. I remember everything. Change locks to re-entrant locks, and we have to do this because currently recursively calling a lock in changed attribute list which is causing a deadlock, have to use a re-entrant lock to recursively acquire and release True dat. True dat. Alright, so let's just do that real quick. I don't even know why I put that in things to do, just in case I didn't finish it. Because this is actually dangerous work. I don't want to fuck this up. My hour, I got 4 more minutes left until I hit the hour mark. So let's go ahead and do this. So let's go up to the tippity top here, and I think all we need to do is change this to R lock. Like, I think that's all. Let me look for other locks. Like, what other locks am I using? So we're gonna go Control Shift F, and we're looking for all the instances of lock throughout the entire project, and I do mean the entire project. Yeah, I don't think I searched for this the proper way. I could have just put like dot lock or whatever. Or threading dot. Yeah, I'm an idiot. Where is it originally assigned? And change attribute list. My eye is like itching me, dude. I don't know what the deal is. Bothering me. Alright, so threading dot. Well, threading dot, we use threading dot for a few different things, but it's less to look for. There we go. So we have the con 1 lock, con 2 lock. I don't think we need re-entrant lock for those. Probably not. Now this one, the locks which we use to handle the C1, C2 to C2, C1 transfer list, since they will be handled by both client threads. Yeah, I'm not sure about these two. So I'm gonna put a comment here, a caution comment. So 1, 2, 3, 4, 5, 6, and then we're doing Control Shift, bam, and this is gonna be below line. We should change it to say below 2 lines, plural. Comment created 9, 20, 7, 24. Why did I do that? Because I hit the wrong button. Do I need to change these to re-entrant locks instead of regular locks? Only required if we are going to recursively acquire the locks. True. Now let's go to change attribute list. So we change this to R lock. Now we should be able to, and what we also need to do, let's review all lock instances, and this is to ensure we are not missing places wherein we should be using lock. Found a couple of these instances associated with changed attribute list.py. Yeah. Alright, so that should fix that issue. Oh, 40 seconds till the break, boys. So we're dude, we made it. We've arrived. Control F. Let's go back. Oh, where is it? Okay, so this is the spot. So this is a recursive lock acquisition. This is why we need our re-entrant locks for this. For the changed, try this again. For the changed attribute list objects. I don't need all those exclamation points, bro. Alright, so with the lock, and this is actually a re-entrant lock, we you know what? I want to change. Why is there so many? I don't need to call it a re-entrant lock. I can just leave it. It doesn't need to be called a re-entrant lock. Actually, I want to do that. I want to be specific. Okay, here we go. C1 cal, re-entrant lock. Let's keep going. Just because I don't want to accidentally forget for whatever reason that we're supposed to be, you know, that we're dealing with a re-entrant lock, because that whole double acquisition, double release thing is, you know, it can get ugly there. So let's go over to, where are we at? This is actually the C1 cal re-entrant lock, and then this is going to be C2 cal re-entrant lock. Oh, there goes my timer. Alright, I'm going to take a little break and reset while I set my timer to 5 minutes. Just 7 minutes. About that. Alright, and then I'll review re-entrant lock. So let me go right here to, I'll remember, it's only 6 minutes. Hopefully I don't forget anything in 6 minutes. That would be depressing. this last hour. Just gonna do 2 hours today. So let me reset my timer back to an hour. And I'll just throw a timer off a Temu for like $2. Alright, there we go. Set back to an hour. And let's do this. Okay. So we were in the process of modifying this lock to a reentrant lock, and now we have to, let's see, cal list function, object A, cal2 reentrant lock. Alright, so this width is going to acquire and release it after this function is done being called. And inside of the cal list function, we are using the reentrant lock again, which is going to acquire it and then release it. So it's going to get acquired, then it's going to get acquired again right here, and then when this is done, it's going to release it, and then it's going to be released again after this. And this should make sure that the data gets appended to the list. Now we can enable this, but like I'm trying to think, how can I make this only log in the case of this rare bug occurrence? Well, couldn't I check to see? Well, that would be circular importing, because everything imports changed attribute list. So I can't import game. I don't think I would be able to. You know what I mean? I don't think I would be able to import game here, because game is importing change attribute list, or at least portions of it, you know what I mean? Pieces of it. And I'm still, honestly, I have a lot of experience with importing, but I'm still not 100% sure, like, if you can import an object from a module, and then in that module import an object, you know, like circularly sort of thing. But I don't think you can. I think it goes like the module has to be compiled, or Python doesn't actually compile per se, but it runs through the script first, and as long as you're referencing another module, if you're importing another module, and then in that module you're importing the same, you know, it's not gonna let you do that, I don't think, even if it's just like a little part of it and not like the entire module. I don't know. Let me ask Jibbity Chibbity about this. Need a little more of my boost, my mushroom blend, my vitamin, and some caffeine and theanine to get me nice and cranked up again. Okay, fellas. Yeah, I don't think I can do that. But that would be another thing that I could do is I could create a third object that reflects the game object, the game state, because we want to check, we want it to print this log only in the case wherein one of the game states is still equal to waiting other player. So if we could import the game state, we could get away with that, but I don't think we can. So here's a simple way to test it. Here's what we'll do. We're gonna go right here. I'll put this. I'm gonna say if p1 game dot game state in waiting, or not in, is equal to waiting other player. Well, and I could actually do if waiting other player in p1 game state, and then comma p2 game state. Yeah, so yeah, we could do that totally. Totally, dude. Waiting other player in p1 game state. So I'm gonna go up here. I'm gonna say from game import p1 game, p2 game. I mean, that's where it's instantiated, I think. So, oh, dude, a little bit of the aluminum foil. If you ever bite aluminum foil when you go to get gum, it's so terrible. It's like the worst pain on your tooth. It's so fucking bad, dude. So let's go over there. Invalid syntax. Oh, I see. I don't know how I did that. I whiffed it there. I did the same thing right there. Don't know how I did that. Okay. Yeah, we can't do it due to circular import. Yeah, we cannot import C1 change attribute list from partially initialized module change attribute list. Yep. So we can't do that. What we can do. Trying to think. I know there's a way. There's always a way. Which I know. Okay. So since this is a very specific thing wherein we are checking, this is always gonna have the game state attribute passed to it. So we got lucky here. We can actually just print out, or rather check, the data. So let me see exactly how we reference this. So the data is what? The cal tube, right? So calloc list function, it's the third argument in calloc. So first, second, third. So it's the cal tube. Okay. So the cal tube is going to be 0, 1, 2. So the cal tube itself consists of I'm so smart. I'm so smart. So the cal tube consists of game, game state, and val. So we're looking for 0, 1. So if index 1, so index 1 of the cal tube, it's gonna call the data transfer function 1, 2, 3. Third object is gonna be the cal tube. Okay, and then it's going to pass the, well, it reassigns cal tube to be more extensive, to have more elements, but it still maintains the original elements at index 1, 2, and 3. So we're looking for cal tube 0, 1. So we're looking for cal tube at 1, which is actually going to be index 0, 1, 2 relative to the cal tube that is passed to calloc list function. So we want to grab data at index 0, 1, 2 to get cal tube 1, which would be game state. Data at index 2. So let's go here, and that is data is the third object. Yep, cal tube is the third object. So we're gonna say if data at index 2 is equal to game state, then then we'll say if data at 3 is equal to waiting, or rather the draw 1, because that's what it's being changed to. This is the val it's being changed to, so this would be 0, 1, 2, data transfer function cal tube at index 2. So we go to change attribute list, data transfer function cal tube at index 2. Whoa, whoa. Yeah, I'm firing on all cylinders right now. I can feel it. So yeah, index 2, 0, 1, 2 is going to be index 3. So 0, 1, 2, 3 relative to the calloc list function. Yeah, so we're looking for data 3. Data 3 is going to be the actual value. So if we go up here and then we say if data 3 is equal to the draw 1, and it is in the string format like that, so yeah, it should be game state for data 2, and then the draw 1, and I can just literally copy this to make sure I don't like fuck it up, which of course is correct because I'm the man and I get it right. But yeah, so only if data 2 is equal to game state and then data 3 is equal to the draw 1, that is the instance in which we have called this function to modify the game state to the draw 1. And that is the only time throughout the entire game that this happens. So yeah, we can actually just do an and here. We can say if data 2 is equal to game state and data 3 is equal to the draw 1. So it's going to check data 2 first. If that's not equal to game state, it's just going to break out of this if and. It's going to exit out right here. If it is equal to game state, it's going to check that actual game state value to see if it's equal to the draw 1. If it is, then and only then, it's going to do the if a list is equal to c1 change attribute list, which is correct, right? If a list is equal to c1 change attribute list, we're going to print out the change attribute list. 1 a list equals the list. So it's going to let us know that if in the case of this bug, it's going to get all the way up to the point of changing the draw 1 up to the very last step before the server logic on the client thread handles sending that data over the network. The final point on the main thread is appending that game state, the draw 1 data to the associated change attribute list. So it's gonna print out this log if it's getting appended to that change attribute list. If it is getting appended to that change attribute list, then we know that it's not like the problem isn't main thread. We can look further, which would be the client thread and like logic that checks for population of the change attribute list, and maybe we're clearing the change attribute list before it should be in certain rare instances because of some bad logic, whatever. So this is going to help us figure out the problem. So we're going to triple check this real quick. Data 2 is equal to game state, and data 3 is equal to draw 1. Data is caltube. Caltube is passed to data transfer function as the third object, which it is, and it consists of 3 elements: game, game state, and val. We need game state and val, which is index 1 and 2. So we go over here. We got the caltube, which is going to be passed to the next, well, it's going to be reassigned actually right here, and its indexes are going to be changed to 0, 1, 2, and 3. So 2 and 3. So yeah, caltube is passed to the calloc list function, which refers to the caltube as in the namespace of data. And then we're looking for 0, 1, 2, and 3. So data at 2 and 3. So yeah, data at 2, and then data at 3 for the actual value, game state, and the draw 1. And we did use equal to and not equals. So we're good here, boys. And then we check if a list is equal to c1 change attribute list, the custom logger should be like da-da-da. Change attribute list pi 1 a list is equal to a list. Great job. If a list is equal to c2 change attribute list, blah, 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 blah. Good job. Now we can get rid of that line. Created for testing purposes, remove and finish. Specifically created for debugging, waiting, other player bug. This should only ever log when the draw 1 is changing the game state to the draw 1. We are testing this because it looks as if we are not sending this data from server side to client side. this helps us determine if it's main thread issue or client thread issue. Yeah. Alright, so let's go to, which I shouldn't have jumped ahead like this because I'm kind of dumb. I should have kept looking for trace back print log. Whoa, 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 whoa. Slow down, dude. Alright. So we're looking for the send section and let's see. Send receive verification application send section. There we go. Yeah, I did check this. I was like, damn, did I not check this first? But I did. So it seems, yeah, it seems to be some sort of race condition issue. If, like, just straight up, that seems to be what it is. It's, well, it's either, it might not be a race condition issue. It could just be a data transfer logic issue. But we have narrowed it down, and this log is going to help us find it in the future. So I'm going to write a little bit in debug file to note what I just did. So let's go over here to bugs debug and waiting other player. We'll put added in logging test code into change attribute list, which will or should log population of the associated change attribute list. Only in the case of game state being changed to colon. Did this because it looks like that data isn't being sent to from SS to CS for whatever reason. If we see that the log shows the associated changed attribute list as populated, then we know it's not a main thread issue, but is a CT issue, most likely a data transfer logic flaw. Okay, yeah. And then we say if it doesn't log, verify that test log logic is correct. If that logic dictates that it surely should have logged it as populated, then we know something is wrong on the main thread side, and that would be like change attribute list, pi logic, or something related. Okay, cool. So that's good progress for that one. And I was thinking what we could actually do is we could log it every time the data is game state. Just as a catch-all for game state changes. It's very rare that we change the game state. But I'm pretty sure that this would, like, this is, I'm like 99.9% certain this should work for what we're trying to do to catch that exact instance. Anyway, so there's really nothing else I can do here. One thing I can check, which I needed to check anyway, is a good thing to check, is the locks. So what we're gonna do is, I'll just leave these files open. We'll go over here and we say review all lock instances to ensure we're not missing places wherein we should be using a lock. Locks, re-entrant, locks. Find a couple of these instances associated with change attribute list pod. Okay, so let's do Control Shift F and then we'll just type in lock and let's just review everywhere where we are using a lock. Okay, make sure we're not messing anything up. So this is where we create the C1 and C2 re-entrant lock for the change attribute list. Then this needs to be changed. We change this parameter to be called a re-entrant lock instead of just lock. Right. Uses a re-entrant lock. Okay. With re-entrant lock, and then oh yeah, we need it. Yeah, we have to use the re-entrant lock there because so we have the re-entrant lock assignment. We use the re-entrant lock, and then we assign re-entrant lock. We use the re-entrant lock. All that's good. We use the re-entrant lock here to call recursively the re-entrant lock again, which is going to handle the proper acquisition and release of it. So that's good. Okay. And why we import those? We don't use them. Wonder why I did that. Okay, so this is with C1 cal lock. Is this in player? Oh, so we actually do need that. Alright. That's good code, but why does it show that it doesn't know what C1 cal lock is? I don't understand. What if it's because of the way, I don't know, I'm pretty sure it would work, like was I asking? I'm like a goldfish. I don't forgot what the hell I was thinking about, bro. With C1 cal lock, with C2 cal lock. Oh right, I was curious about whether I could import it this way using the names, like the method of importing from change attribute list import such and such, as opposed to import the entire module and then access it using the dot notation. Yeah, it's ChatGPT. I'm pretty certain I can do it like this. Actually, I don't want to ask ChatGPT that. I need to test that myself. So what we're gonna do is, let's just go right here. Pretty sure I already tested this before. Let me just look for a lock. Here we go. Okay, 714. Okay. Reminder that copy module locks. Here we go. With lock versus if versus match. Reminder that calling with lock takes almost no overhead compared to using an if or match statement. It's quicker to just always use the lock instead of checking to see if there is more than one thread. Oh, okay, right. Which is the same thing as to see if they're like running any if conditional, right? Why did it scroll through that so fast? Match threading dot enumerate. Oh, because threading enumerate. No, so threading enumerate is going to take way longer than just using a lock, but an if elif might be quicker. All right. Anyway, we have locked. Reminder that you can use locked to determine if a lock is acquired. Okay, I actually forgot that, which is funny. Okay, yeah. So I apparently I didn't test it, or if I did, I didn't save it in the file. So what we're gonna do is we'll say import threading, because that's the module we get lock from. We're gonna then say L equals threading dot lock. It has to be capital L lock, and then we'll say L dot acquire here. All right, and then we're gonna have another file. So we'll create a new file here called testlock.py, and then we're gonna say import, or rather, what's the syntax we want to use? We want to say from test reminders import L, which is that lock, and then we want to say L dot acquire, if L dot locked, or we can just do print L, print L dot locked, and then let's run that. Okay, so it is locked, which means when we import it using this this format of importing, where we're importing the lock object directly from the module, it is importing that actual object. Like, it's not a copy of that object. It acts such that whenever we acquire the lock in test reminders and then imported it into test lock file, it is considered locked still. And then we can verify this by saying, well, we can do L.release, and then over here in test reminders we can find this function called F, which will say print L.locked. So, and then we will Well, we can just do threading.sleep, I think. Threading.sleep for 1 second, and then we can run F. Is that the right? I don't know if that's right. Threading has no attribute sleep. It's time. Time.sleep. Yeah, it's time.sleep, not silly. At least I think it is. Yeah. So lock. Well, actually, um, well, actually, it should be released. So that's an issue because. Well, actually, yeah, this has no. Never mind, I'm an idiot. So, anyway, that I think that's enough to let me know that what I'm like assuming is true as far as this lock logic here. I don't think there's anything else I need to like really go through to verify that. I was gonna just show that it would do the same thing, like reflected back, but I don't need to do that. So I guess I'll save this one and we'll call it locks imported as from module import lock works. And 927, 24. Reminder that importing a lock using from X import L works as suspected. It handles the same object, just like importing a mutable object. Yeah, true. Wait, just like importing, yeah, a mutable object. When you import a mutable object like that, it works as you would expect. If you import an immutable object like that, it doesn't work. It creates a new instance of that object. Okay, so we'll just leave that. Save it. So what was I doing exactly? Oh yeah, I was looking through all the different instances of lock. So let's go back to Control Shift F. We're looking for lock. Alright, we got all the way through here with reentrant lock. All that's good. We're actually through these files. Where we specifically, okay, we're right here in player. And I wanted to see if we could import the lock this way, and we can. So we're good on that. So that lock, that syntax is correct. All right, let's just keep going. Look through all these gridlocked. Server. Locks. All right, so we have locks. Lock threading lock. Threading lock. So con1 lock I don't think needs to be a reentrant lock. I thought I put a note for this, didn't I? Or that, I guess that must have been for something else. This is for server, right? Low line. Do these need to be reentrant locks? Quite sure they don't, but not 100% sure. Alright, so we'll take care of that at some point in the future. C1 to, so this is the one I checked and didn't put the note by. These more than likely it may need to be reentry locks. Maybe not though. Okay, so now we're in threaded client. We're importing the global lock. Okay, makes sense. That should work as intended. Transfer lock equals self C2 to C1 transfer lock. Alright, so we're just assigning these. Then we acquire the transfer lock to handle. Well, you know, the issue isn't really looking for lock. We really need to search for all shared objects. So I'll do that as well. We're gonna change locks to reentrant locks. Check all of them to see if they need to be reentrant or regular locks. Alright. Review lock instances to ensure proper logic, and then review all instances of shared objects server side to ensure they are being properly locked. Yeah, that's true. Okay, we got 19 minutes left here, and we're gonna call it quits. So, which is really more like 15 minutes. Let's finish strong here. Alright. Where are we at? There we go. So we have the transfer lock acquire. Okay. And then we use the transfer list, which is what we're locking. Then we release the lock. Okay. Now, and this is not going to be recursive or anything, so we don't need reentrant so far. Then with conlock, we're accessing that connection, so we do need the conlock there. Then we use with transfer lock. Okay, that's fine. Then this else is for if the length of the transfer list is greater than 0, we have to make sure we're releasing the lock in the case that it's not greater than 0, otherwise it would remain acquired, so we actually have to keep that. If current client is equal to 1, conlock equals self-con1 lock, then we use the conlock on the connection. Let's do the same thing here, except this is with connection 2, and then here we use it again for send all again, and see lock. Okay. Alright. And we have C1 calloc acquire. What's this? Okay. What do we not use with? Let me see. Okay, then we check the length of the list, we release it, and then we have the else to release it in that case. But we could, this is fine, calloc equals C1 calloc, conlock equals other conlock equals sub 2 conlock with calloc. Okay, which has been released, so we're good so far. That's good. Same thing again, we acquire C2, we release it, else we release it, assign these different variables for the different locks. We then use the calloc, which is fine. And that's for the change attribute list. I don't know. Yeah, we do need it for both of those lines, so we're good on that. calloc list function, which is going to use the calloc, but since we're passing in the associated change attribute list, doesn't that mean we need to use the lock here? Yeah. So yeah, it's the actual calloc. So this is why we had to make it a reentrant lock, because this is recursive. So we actually need to say with lock or with calloc. We'll then do this. So we are gonna use the calloc variable to use the context manager to call calloc list function. So let's go over here. Calloc list function is going to have a list method data reentrant lock. Where were we exactly? We're in server. Okay. So we say with calloc list function, a list is the associated change attribute list R, and then lock equals calloc. So we use the calloc, and then we use the reentrant lock again recursively. So we do need that to be a reentrant lock, and it already is a reentrant lock because the C1 cal reentrant lock. So we actually need to change all the names of those. I forgot. Change all names of C1 and C2 cal lock to reentrant lock. Change all instances of C1 cal lock, C1 or C2 cal lock to C1, C2 reentrant cal lock. Isn't that what it's called? Reentrant cal lock. So anyway, yeah, C2 cal reentrant lock. Is that right? C2. Now it's messed that up. C1, C2 cal reentrant lock. Yeah. Alright, now let's go back over here and where we at? Where I'm at. With cal lock. Current client do not send data rules equal to true. Current client change attribute list remove to with cal lock. So yeah, this is a recursive acquisition for that lock, and that's fine, right? Yeah, because it'll release it immediately after. And we need it because we're handling the associated change attribute list. The associated change attribute list is the actual list. Just reference the pointer. Okay, so we're at line 805. So went backwards just a bit. Alright. Just keep going. Okay, so we'll change all the instances of that in a little bit. So we have calloc. This function. So right, yeah, this is another instance where we need to basically every instance of calloc list function we need to have we need to have a recursive lock acquisition using the context manager. So right here we need to say with calloc because we're handling the associated change attribute list here, which is indeed the actual C1 or C2 change attribute list. What is the scroll bar at? Do that. It's my place. Okay, there we go. Change attribute list copy with cal lock. We'll then do remove all entries from this associated change attribute list, and yeah, we're gonna put this inside the context manager so that the associated change attribute list access is locked, since it is a shared object always, and this is on server file, so we do need to implement the logs there. So this should be good to go. So this is 840. And I tell you what, I feel good today on the coding. As far as coding goes, I quit going to the gym for the past few days because my back, for the first time, I usually go to the gym like 5 or 6 times a week, on top of working at UPS, and I haven't been in the gym in like two days because of my back, and I guess just having like more energy from not using all my energy at the gym makes a difference in my ability to like think critically here. With coding, it's like very easy compared to normally. Just goes to show you, like, physical work also affects your like capacity to do mental work, you know. It all draws from your body. So physical work is mental work too. I think mental work is physical work though. So we have it with other com lock, old feature. Okay, so we did it. We made it all the way through. Okay, so we have 8 minutes and 55 seconds left. What I'm going to do is 5 minutes is going to be for finishing up, so we got 3 more minutes and 45 seconds. We're going to go through and do this last task, which is review change all instances of C1 C2 cal lock. So let's just do Control Shift F, and we're going to say cal lock. And actually, let me go right here, review all lock instances to ensure proper logic. Done. And then this is not done. Change all instances of, and then is this done? Right now it's not done, but it's about to be. So let's do cal lock, and let's find. So these need to be changed. Yeah, let's just verify. Go to change attribute list. Cal lock list function at the top here. Yeah, they should be called C1 cal re-entrant lock. So what we can do is we'll do Control Shift F, and we're looking for C1 cal lock, and we're gonna find all instances of that, and we're gonna go through here, Control or Shift F, and we're gonna paste in. We'll just write it in C1 cal lock, and then we'll replace it with C1 cal re-entrant lock. So let's find that instance, and we're going to replace it. Okay, and then and this is good because this is gonna help me to ensure that I'm always remembering this is a re-entrant lock. It's no longer just a regular lock. And there's 90. Wait a second, what's going on here? I'm like, did I just make a mistake? I don't know what I did, boys. Alright, now let's change this to C1 catlock, or C2. And we're going to change this to C2 as well. See that? See right there? What song is this? I know it. What is it? I know this. Oh, yeah. That's a pretty good song. It's alright. Not my first choice, but they did it. It sounded like they did a good rendition of it. Alright, so let's go over here. We're done. And why are all these files open on this side? What was going on with that? I don't think I messed anything up though. So let's just close all this shit. Go back over here. Review all lock instances. Done. Didn't do that. And did that. So we'll say worked on waiting other player bug, made good progress, debugging it. This involved reviewing lock logic, which was found to be slightly in some places, such as changed attribute list by we ended up changing regular locks to reentrant locks for recursive lock acquisition. I love that word, acquisition. Makes you feel like a damn genius when you say it, doesn't it? Alright, so now we're gonna say we're done. We're done. So 4.8 to 4.10 is we're gonna stage commit and push these changes. So let's our finishing time at 4:10, which is so from 1:53 to 4:10. That's, let's say, basically 2 to 4:10 is 2 hours and 10 minutes. So we did 2 hours and 15 minutes, a little bit over. So we put 2.25 hours, which is almost exactly correct. Now we're cd to the root project directory. We're going to do git branch to check the branch, make sure we're on secondary, which we are. Now we can do git add dot to add everything. Ignore those LF warnings. Do git commit -m, double quotes, paste in our devlog, double quotes to close it. There goes our timer. We're done. I'm going to turn off my timer. And then we can do git push Canasta secondary, which pushes to the Canasta repository at the secondary branch. So it's pushing it up to the cloud on GitHub, and it completed. So we're done there. Now we can go to get Kodak showing you his back molars. The molars way in the back. Is that what they're called? Molars? Your molars are the ones in the back, ain't they? I don't know. So let's go to projects. We're gonna go to Canasta, copy this little one, go to the backup, and delete the little one there. Now we're gonna paste in the new boy. Wait for that to complete. We're gonna jump into it to give it the old discount double check. Go to devlog, go to the end. 27th is the date of today. Is today's date, so we know that our backup is correctly backed up locally. So now we have a local backup just in case shit goes wrong. And that's it, dude. So we're done for the day. Hope you have a good weekend, and maybe we'll get some more coding done Monday and finish up this project. Very close, almost done. I say almost done, it's always almost done, isn't it? But yeah, almost done debugging and finishing those non-pressing issues. And yeah, other than that, it's just debug it, which is mostly done already, honestly, and then move on to the next stage where we can deploy it. We can actually like get it hosted some way so that, you know, it is an actual legit project that someone can download, and I can go ahead and start applying for jobs and show a potential employer my super awesome badass project.